Hi, in this video you will learn all about the safety of the Hyperloop system, which is likely the most important aspect before anyone travels with the Hyperloop. Safety is by far the most important aspect of human transportation, since no one will travel in a vehicle that they can't trust to safely transport them. First, we will discuss safety on the pod itself. Then you will learn about the safety of the tubes and network. And lastly, we will be looking about safety in the Hyperloop stations. When looking at the safety for passengers, in case of a malfunction in the pod itself, we can take a look at airplanes. First of all, when something happens in the pressure cabin, the safety systems will have to work almost exactly the same, mainly ensuring that the emergency is suppressed and habitable conditions are maintained. This means that, for example, fires have to be extinguished automatically, and a means to solve pressure leaks has to be present. If we assume that this part of the safety is handled, our next logical step will be to look at ways to safely exit the passenger from the pod to the tube. This comes down to emergency exits, which require airlocks. These will greatly increase the cost of the system, but are unavoidable. Their magnitude is something, however, that can be decreased. So our goal will be to maximize safety, but also minimize the cost. Although it is maybe not logical at first sight, the safety concepts for a Hyperloop can be taken from that of airplanes. For this purpose, we can look at the safe haven concept. Airplanes are built in such a fashion that when an emergency occurs at cruising altitude, these planes are still able to land. When designing such a system for Hyperloop, this means that the emergency exits needed can greatly be reduced, perhaps to intervals of 15 kilometers. For the design of Hyperloop, this means that all systems should either be made fully passive or redundant in such a way that during a failure, the passengers are safe and the vehicle can be moved to the nearest emergency exit. From this, an EDS, electrodynamic suspension system, is preferable, as while moving, the pod will always be able to levitate if the suspension remains intact, while active magnets would stop working when power is lost. When taking all these factors into account, we can ensure that the tubes can always be used safely, and by automating a lot of this, also human mistakes can be filtered out of the system. While this automation might not be profitable for existing transportation, the fact that we're creating a new mode of transportation means that such tools can be developed and used from the start. This makes it less costly than changing an existing system. Lastly, when we look at safety inside the station, we again have a look at airports. As we are very likely to cross-country borders during a trip, security will have to be similar to airports. Thus, people will have to go through customs, like you do at airports. Also, cameras and other safety scans will be present. In case of an emergency, tubes would have to be present that pass by the station at lower speeds and redirect pods to other nearby stations. So to summarize, we have looked at three aspects of safety: safety inside the pod, inside the network, and inside the station, and can come to a conclusion connecting all of them. Although we have to think this out very carefully, we can be smart and simply have a look at existing systems. We borrow their ideas and fit them to our own application.